Hi, hello everyone. So this is our second video dealing with adding and subtracting rational expressions. So this is the second part, part B, where we are dealing with rational expressions that have different denominators. So in the first video, I've covered the situation where the denominators are the same. And now this is the video where we have to do something. And that usually involves finding another denominator. Sometimes maybe an easier case would be the LCD, the least common denominator, but it doesn't have to be the least. The whole goal is that we manipulate the fractions or the expressions so that both denominators have to be identical. And only then we can begin with the operation of either subtraction or addition, whichever case may be. Okay, so don't worry so much about the idea of finding the LCD because I'm going to show you a shortcut in order to handle these problems right here. All right, so let's take a look. I already copied these problems into the whiteboard. So let's do the first one right here. And I have an expression where the first term is 7 over 3x squared and minus 5 over 2x. Notice that the denominators are different. I cannot do the same thing as I did before and do 7 minus 5 because I don't know what to put for the denominator. So what do? We have to have both denominators being equal. And in this case, I have 3x squared, and in this case, I just have 2x. So the second fraction is missing an x. So I'm going to multiply by x. That's the first thing I'm going to do. And the reason for that is now I have an x squared here, and I have an x squared there. But keep in mind, if you do this on the denominator, you have to do it on the numerator as well. So I have a 5x in the numerator right now. I have a 3 here and I have a 2 there. So I need a number that is identical in both cases. This is what we call the LCD. It's a smallest multiple of both numbers. But the easiest thing that you can do to find that number is to multiply 3 times 2. So the denominator that you're going to use is you're going to multiply the 3 by 2. You get 6x squared. And you're going to multiply the 2 by 3 to get the 6x squared. And notice now that they are the same. But keep in mind, if you multiply the 3 by 2, you have to multiply the 7 by 2 as well. And if you multiply this denominator by 3, you have to multiply the numerator as well. So your new fraction will look like this. Both denominators are the same at this point. But the numerator for the first fraction is 14. The numerator for the second fraction is 15x. Okay, now that both denominators are the same, it's pretty much the same as the video in part A. You're going to keep that denominator the same, and you are going to combine the terms in the numerator. And you're going to see if it's possible for us to simplify anything. Okay, so there's nothing I can factor in the denominator, and I'm going to take a look in the numerator to see if I can simplify anything. Well, 14 is only divisible by 2 and 7. This is only divisible by 3 and 5, so there's nothing I can do. So this is my final answer for that particular problem. Okay, this is all you have to do. And the key thing being making sure the denominators are the same. And after you do, you may have to adjust the numerators just like I did over here. And notice that if I simplify, when you simplify the new fractions, they should be identical to the original. So if I simplify this by 2, 14 divided by 2, I get 7. 6 divided by 2, I get 3. Notice that this is exactly what I started with, so the fraction is correct. The same goes for the 15x over 6x squared. Okay, so let's see another example. This is the second case. Here is the second case, where now, again, the denominators are different. Cannot add them as they are. And in this case, I notice that I have to factor it first. So I am going to leave the first fraction the same. And I have to identify what kind of factoring technique this is. I recognize this as difference of squares because I have two terms with a minus in the middle and the exponent here being a multiple of 2. So we have to go back and find out how to factor difference of squares. I remember that it's going to have two terms. I will split the two variables. One is going to be positive, the other is going to be negative. And I need two numbers, identical numbers, whose product is 16. So obviously 4 and 4. Now I have both fractions fully factored and the denominators don't match. All I need to do is make sure that they do match. So this fraction has only one factor. This fraction has 2. So the only thing that this fraction is missing is the factor x plus 4. So I am going to include it in this fraction right here. So I am not going to change the second fraction. Look what I'm going to do. And for the first fraction, I am, because my goal is to make sure the denominators are equal, I am going to introduce this factor into the first fraction. And I'm even going to write it in a different color. Maybe I'll write it in green. Okay. And remember, if you write it in the denominator, it must be also in the numerator. And leave the 5x that was originally there from the start. Notice that now both fractions have the same denominator. And if they do, you can just combine the numerators under a single fraction. So the denominator is going to be the same. This numerator has to be expanded. 5x times x, 5x squared. 5x plus, times 4 is 20x. And I have the plus 8 here. So now I have to consider the possibility that I can simplify this remaining fraction right here. There's nothing I can simplify in the denominator, it stays the same. But this is a trinomial with leading coefficient greater than 1. And I have to see if I can factor that trinomial. I'm going to do this on the side. So I need a number for my product that is 5 times 8. And I need a sum that is equal to 20. I have to find out if I have such numbers. So let's go through some of them. Let's see, I have, it's 1 and 40 is a possibility, 2 and 20 for the product, maybe 4 and 10, and maybe 5 and 8. That might be everything. Okay. So let's see if we didn't miss anything. 1 and 40, 2 and 20, 3 doesn't work, 4 and 10 works, 5 and 8. And is there anything else? I think that's it. So out of these possible 4 pairs, I have to find out if there is one whose sum is 20. And there isn't, because this is 1 and 40 is too big. 2 and 20, nope. 4 and 10, also no. And 5 and 8, also no. So what does that mean? It means that this is not factorable, which means that this is my final answer. So you would write just the final answer as is. But we have to check. We always have to check. And leave it at that. Stop. This is our final answer. Okay, obviously, you always have to check to see if you did make a mistake, but I guess in this case, we did not. Okay, so this is the second case. Hopefully, the third case, we are going to be able to simplify something. This is the third case. The third example I have in here. So let's see. Again, the denominators are different. I need to first factor this. Again, it's a trinomial with leading coefficient 1. So I need to find two numbers whose product is 12 and whose sum is -7, right? So the product is always this. The sum is always that. So I maybe have 1 and 12, 2 and 6, and 3 and 4. Out of these three possible pairs, I have to see one that can give me a sum of -7, and the only possibility is this. And so I'm going to write it here, but I have to see that the sum is -7. So how do I can get a sum of -7? If I add the two as they are, I get +7. But notice that if both of them are negative, then I have a sum of -3 plus -4, which is -7, and their product is +12. So this is the number that I want. I will write my factored expression this way. So this is going to replace that. I'm going to write it here. So here is my, and by the way, notice that it's not X, it's Y, right? So be very careful. So Y -3, Y -4, Y -3, copy the numerator as it is. Very good. It's fully factored. Now, your job is to make sure that you do the operation addition, but you cannot do it because the two denominators are different. But in this case, it's very easy again, because the second fraction is only missing this factor right here. So all you have to do to match it is write it on the right side. And again, if you write it on the denominator, you have to make sure you also put the same factor in the numerator. Once you have the same identical denominators, you can combine the fraction into one. As I'm doing right here, and you can combine and do the operation on the numerator. So notice that I have to expand the two. Make sure you don't make a mistake. 2y -8. Still cannot do anything with the denominator. Leave it the same. But now I have 4y, and I have +1. At this point, I will try to factor anything. There's nothing to factor in the denominator because it's already fully factored, and I cannot factor anything out of the numerator. In that case, this is my final answer. However, in a different problem, it may be possible to factor the numerator further, and you should try that in case some of it may cancel with these other two factors. But in this case, I cannot proceed any further. This is my final answer. Okay? So this is what you have to do in the event your denominators are different. You must factor everything. And once you are sure that both denominators are the same, you can combine and perform the operation in the numerator to simplify and get the final answer.